freight efficiency with NACFE's Mike Roth and Friends.
Here in episode 111, we're joined by Giorgio Rizzoni. He's a professor at The Ohio State University and director of the Center for Automotive Research, where he talks about how he came to Ohio State and explains the role of a research center in educating the next generation of engineers. He also talks about his role in developing engine controls and emissions controls a few years ago, or maybe a few decades ago. He also talks about his work on a DOE project on hybrid electric refuse trucks, what he is excited about in trucking today, and the importance of writing. Today, we're joined by Dr. Giorgio Rizzoni, who is professor at The Ohio State University and director of the Center for Automotive Research. Giorgio, I'm really excited to have you on today. You're a unique friend in being at a university for 40 years now and splitting your time between that school up north and Ohio State. I always ask my guests how we became friends.
Okay.
So do you know how we met and became friends, or about what timing that might have been?
I'm trying to remember because it seems like we've known each other for a very long time. I'm trying to remember the very first instance. Do you remember?
Yeah, so I have a shot at it. So I spent 12 years at Cummins and then 13 at International Truck. I was based out of Fort Wayne, Indiana, short, 2.5 hour drive from Columbus. I think, Giorgio, that as I was researching technologies to improve fuel economy on trucks and engines and transmissions and everything, that I think I came over and met you at my alma mater to try to get some thinking going. We'll put a pin in this and say it was around 2007 or 8. So how does a man who got 3 degrees from that school up north, and if you're listening to this, you don't know what I'm talking about, that's the University of Michigan. How does it?
Yeah, there could be some people who don't know that, right?
There could be, right? But how does he then turn around and become an educator and a leader of research at Ohio State, or the Ohio State University, for what, 30, 40 years now, Giorgio?
35 years. Do you remember a Professor Ernie Doblin?
Oh, yeah.
So my story at Ohio State begins with Ernie Doblin because at one point, after being on the faculty here for forever and a day, he announced his retirement. And the department decided that to replace Ernie Doblin, they needed to hire 2 faculty. And so they actually hired 2 of us in the end. And I had done my studies at that school up north. I studied as an electrical engineer. But when I was a graduate student and I came across the person who became my PhD advisor, he was beginning a vehicular electronics laboratory with funding from the Bendix Corporation. And he had negotiated somehow with the Department of Mechanical Engineering to have some lab space in the automotive lab. And so we were a small group of electrical engineers doing sensors, electronics, and control on internal combustion engines. I actually personally installed the first digitally controlled dynamometer setup at U of M with a company called Digilog. And so I don't have any degrees in mechanical engineering, but I became very familiar with the language, and all of my research revolved around engines, and my passion was motorcycles at that time. And I took apart engines and rebuilt them. I mean, it was one of those things. For me to use what I learned in electronics and apply it to engines was heaven. So we were doing all these work in the early 1980s that was really uncommon. Today, we think of electronics as being part of everything, but back then, they were not. So I spent a little bit of time as a postdoc. I work as a research engineer. I spent a little bit of time as a lecturer at the school up north. And then one day, as I'm thinking, what do I do when I grow up? A friend who was a professor, an assistant professor in mechanical engineering, brings me this copy of Mechanical Engineering magazine, okay, and says, look, there is a position here at Ohio State. They're looking for someone with experience in automotive engineering and electromechanical systems. I thought, okay, sounds like could be interesting. I applied. Well, they gave me an interview. I come for the interview. I love the welcome I had and the environment. I thought it was a very good department. Still is, and it was then. And during part of the conversations with the faculty, the group that did all the teaching in dynamic systems measurements and control asked me, well, if you were to come here, what would you like to teach? Well, I had been a teaching assistant as a graduate student in a measurements course for electrical mechanics, but I saw that they had a mechanical measurements class, which was Ernie Doebelin class, and he wrote a book that is still a reference. Okay, and I said, well, I would love to teach your mechanical measurements class. It was the right answer. What I didn't know was that Ernie was retiring and they were trying to figure out who would teach measurements. Okay. They offered me the position. I accepted it. And I then discovered that the automotive part of this position had to do with the creation of the Center for Automotive Research, which was linked to the growth of Honda in Central Ohio, a relationship with TRC, the Transportation Research Center. So they expected me to do things in the automotive world, and I did. I created, they didn't really have active engine labs. They gave me some test cells, and there was some funding to equip these test cells. And so I developed some engine research programs that were focused mostly on engine control, emissions control. Did work with Ford, with General Motors, with Honda. And it really was, I think in 1993, that I started doing work with Cummins. And with Cummins, I was doing work that touched both their light duty production, the B6 engine that goes in the Dodge pickup trucks, but also I did some work on diagnostics and monitoring, mostly misfire detection for their big engine, like the K19. And so I became acquainted early on with this wonderful world. And by the way, at that time, it was called the Cummins Engine Company. You remember that?
Yeah, I remember.
You remember
Absolutely.
that?
And at that time, about 75% of their global sales was to North American trucking.
Yep.
And, with their globalization and generator sets and military business, construction, all the stuff. I mean, I think that numbers now is down like to 25% or something like that. So, yeah.
So the Cummins experience was my first entry into the world of commercial vehicles and trucks. But, I started working with Cummins in 1993. I still am today. Okay. The topics may have changed, but I developed an appreciation. There are two things that happened. One is this early interaction with Cummins that had me develop an appreciation for the commercial vehicle world, the world of trucks. And the other one was coming to Ohio State, and you talked about agricultural engineering, right? So this world of a land grant university where we have ag engineers, I started learning about the off-highway side of things. They make tractors and combines and things. And guess what? They're powered more or less by the same types of systems that power trucks, right?
As a controls expert, in these commercial vehicles, the way we can customize these engine performance, transmission performance, and so forth for different demands, different duty cycles that we have in trucking has opened up tons of efficiency and safety and all kinds of improvements because now we can make that engine is no longer just solely mechanical. Now we've got electronics and all of this flexibility with these engines
Yep.
To make them do kind of lots of different things that are phenomenal. I mean, you just think about the NOx levels that these engines are putting out are so tiny and minuscule that we'd have never thought that. But right? Do I have that right? I mean, that gives us a lot of flexibility and freedom.
It does. Absolutely true. And the fact that in a commercial vehicle application, you have a much better understanding of the duty cycle allows you to then use this flexibility and the degrees of freedom that you have through electronics to basically optimize the performance and emissions of your engine in the specific situation in which it is applied. I'll give you an example. Many years ago, I worked with Oshkosh Truck on a project funded by the Department of Energy that was to demonstrate a hybrid electric refuse hauling vehicle. That was a fascinating project because one of the things we had to understand was the duty cycle, and there's a lot of hydraulic accessories, right? You've got to lift the bin, you have the packing equipment, you have the dumping action, right? So there is a lot of hydraulic accessories, fluid power systems, and at the same time, the truck operates in the city. It has to move on the highway. It could be in a mountainous, hilly region or in a flat region like you grew up, right? And it was a fascinating job for us to understand duty cycles, including the power takeoff and accessory functions, and try to imagine if you were going to introduce an electrified powertrain, have some energy storage. And by the way, we used supercapacitors back then because batteries were not good enough at that time to recover significant amounts of power. And so, how do you optimize all of that? So, in addition to the electronics, today we also have the opportunity to have, electrical actuation systems on board the vehicle that can give you further degrees of freedom to do optimization.
Right.
Some of this is beginning to appear, right, in the products that are on the road.
So tell us about car. I don't know if I've ever had a guest that runs a university research center or transportation, but I've worked with Northwestern, I've worked with Michigan, I've worked with, don't tell too many people that, but I've worked with you and others, Clemson. There are a number of these around the country. Kind of maybe if you could do two things for me, Giorgio, explain what they are and how they're funded and how they work with students. And then secondly, what makes one different from the next, or are they different from the next? So,
So,
yeah.
everyone is a little different because if you say, oh, I work in a mechanical engineering or mechanical and aerospace engineering department, last week I gave a lecture at NC State, mechanical and aerospace engineering, their land grant school. They're very similar to our MAE department because our degrees are accredited by ABET. We all have the same set of rules and regulations. Research centers each of them is different. And the way this was interpreted at Ohio State when the Center for Automotive Research was created was that because of the sale of our Transportation Research Center to Honda, the state of Ohio received a certain amount of money for this sale of land and facilities. And they said, look, Ohio State, you do a lot of engineering work. You have lots of connections with the automotive industry. Honda will be here. Why don't we give you some of the proceeds from this sale, put them in an endowment called the Transportation Research Endowment Program, and let you do as you will with it to enhance transportation research. So the way this was interpreted by the leaders at the time, being Don Glauer and Larry Kennedy, who was chair of the Department of Mechanical Engineering, they said, let's create a Center for Automotive Research and let's make it an interdisciplinary center. We understand that the transportation industry is broad, so we're not going to be narrow. So here at Ohio State, our center is a cross-disciplinary, interdisciplinary unit. In some ways, my role is similar to that of a department chair or a department head in an academic department, but instead of dealing with the educational mission of the university, I deal with research, with the research mission, and we have our own staff, and then professors who want to educate their graduate students doing research on all kinds of automotive engineering problems, they can use the facilities we have. And it doesn't matter if the professor is in electrical engineering, computer science, material science, mechanical engineering, everyone is welcome. So we tend to work on larger problems that are inherently interdisciplinary. So the growth of electrification, the growth of connectivity and automation in vehicles, these have all been fantastic for us because we were founded to be an interdisciplinary activity.
Yeah. You then also work with industry, and it's a great linkage to industry that probably pulls industry back into the universities, right? Because that's always something that I think a lot of companies want to do, but it's hard to work with students, and they come and go. It's part of some of it needs to be part of an education curriculum and whatever. I got to believe the research centers are a great place to make that linkage between.
Absolutely, it is, and in multiple ways. Of course, We have interactions with industry partners and do research projects with them. And I always like to say that our product, Cummins' product is they make engine propulsion system, generators, whatever it is. Our product are people. We educate the students who are then going to become the brilliant engineers who design the new products at Ford, at Honda, at Cummins, or wherever. So the question is, how do you educate these students in such a way that their know-how is consistent and compatible with what industry needs? We do it by working with industry. And a company that sponsors a project here to do some applied research in some area ultimately may benefit from that research. We hope so. But most certainly, if they train and then recruit the students who work on these projects, what a great deal. I mean, that's a much longer term benefit than just the immediate results of the project.
Right, right. So I'm gonna maybe challenge you a little bit with a question here. I mean, it is around what I do every day, and that's technology that's going to make sense for trucking. Oftentimes, you hear about ACE, automation, connectivity, and electrification. And I've been really thinking about, are these things, um, you know, transformational or not? Is this an evolution or kind of a revolution? And I'm coming around to electric trucks, automation, and now the ability to connect the vehicle to the shop, to the operations. We can now, I mean, there's companies that are pulling trucks in because they are certain that they're going to have a failure in a week
Yeah.
because of the stuff they look at. I mean, that's like mind blowing stuff. So my question for you is, is the trucking industry, who needs to be incredibly safe, reliable, efficient, predictable. There's a lot to deal with trucking. I mean, we need to get medicines places, food places. It's important to society. How do we deal with this technology in a way that makes it successful? And what maybe are some particular things that you think are going to make it, and others that I don't know. You don't have to say which aren't, but what are you most excited about for trucking?
Sure. So, first of all, I have to say that I like the word evolution because I think that this is an industry that, in some ways, has to be somewhat conservative because, as you said, it has to be safe, it has to be reliable, right? So this is not a place where you're going to try to do some dramatically revolutionary things, not knowing what the outcome is going to be. So what I see, and you've hinted at some of the benefits, I see that the evolution of connectivity, communications technologies has enabled things that 10, 20, 30 years ago were not done or not even thinkable, with the benefit of, pick up a practical example. Today, we can imagine reducing the number of empty miles that freight truck carry because we can be more informed about where to pick up loads, how to optimize the operation. This is just one example. So I think that this combination of connectivity and I'll call them, broadly speaking, efficiency, the energy efficiency technologies, I think it's evolving. It is difficult to say, oh, well, tomorrow we're just going to make all this truck electric. Okay. We know that there have been valiant efforts and there have been products on the market, but it's not easy because they need to match the application, the use case, and the technology needs to be as reliable and cost effective. Otherwise, if you don't meet your cost objectives, you will not exist as a business. So I think of it in terms of evolution, and I'll give you an example on the electrification side. We're currently working on a really interesting project with Oak Ridge National Lab and Stanford University. It's a program funded by the Department of Energy, and we're sort of looking at drayage trucks in ports. Would it make sense for those to be electric? And a drayage truck, it's quite interesting. I'm learning a lot about that world of specialty trucks. What surprised me when I first approached them is that they actually cover longer distances than I thought. They'll go 150, like 100 miles easily. And
So, yep, you're exactly right.
we started with Port of Savannah and we looked at the routes that come out of Port of Savannah, and we're going to North Carolina, Tennessee, Georgia, Florida. I mean, they cover a pretty nice range of in the southeast. So the question is, does it make sense for them to be electric? What impact does this have on the productivity and efficiency of the fleet? And there is an adjacent question, which is actually the part Oak Ridge National Lab is working on, which is what type of infrastructure do you need to have to enable the refueling, the recharging of these battery electric trucks? So as part of this process, we have looked into how can you assess with good accuracy the energy requirements that these trucks will face in different seasons. Things like the change in air density, the impact on aerodynamic drag of air density between winter and summer matters. You're going up to Tennessee, you cross some mountains. That matters as well.
Part of this technology and connectivity makes the modal switch much more efficient and reliable.
Yes, it does.
We used to not know anything about the freight or the trucks or where they are, so there was all this wait time and lost time, so you wouldn't dare take freight off of a truck in the old days because it would just take forever to get on another truck to get to its destination. You just decided, all right, well, it's on a truck, get it from point A to point B. I don't care how far it goes or what the emissions are. Now we kind of know a lot more about that. So, hey, I want to ask you something else. This is switching gears, but you and I were both honored with the Society of Automotive Engineers L. Ray Buckendale Award. I'll call it an award. I'm not so sure, it's work. You got to work for the award.
Yeah, it was a lot of work.
Yeah, it is a lot of work, but it's been around 80 years, so a long time. So we're in a small group of 80 people. And what I want to ask you about is about writing and technical writing, because we do a lot of that here at NACFE, and so forth. And it seems to be becoming harder and harder to get engineers or people to write. I've never been a good writer, but when I had to, I did it. You and I both wrote a manuscript for the L. Ray Buckendale. The SAE committee that we're both on, chose last year to not require a manuscript anymore, that you can just come to the annual meeting and provide so it's manuscript and lecture. It was that for 78 years. Now it's just the L. Ray Buckendale lecture. And part of me says, man, that's not right. Giorgio and I did all this work, and so did our friend Rick Mihalik, and Dave Schaller was on. But so what's going on there? Is that are we, TikToking and texting? Have we gotten away from technical writing, and is that a worry or not? Or
That's such a good question, Mike. So I'll give you my thoughts. Of course, let me say we are more experienced. And so I'll give you a more experienced perspective. So first of all, I think the writing is extremely important. And in my job, I spend a considerable amount of my teaching time being a mentor to graduate students and teaching them how to write technical papers, master's thesis, PhD dissertation. So to us, writing is an extremely important thing. And I emphasize this. In fact, I have in my office a stack, I buy them by the box, of a little booklet called The Elements of Style by Strunk and White, which is the best little set of tidbits on how to be a good writer in a simple way. We're not going to write large works of literature, but we need to communicate effectively. So I think that continues to be an extremely important thing. And it is true that today's students are probably less prone to want to do, for one thing, they're not used to writing by hand anymore. Remember, we used to actually write things by hand. So personally, I think it is still a very important thing. The reason for the Buckendale award not having a paper anymore, we're trying to reverse that. Okay, we're good friends who are trying to say, no, we think that a paper is pretty important. So right now,
maybe there's Maybe there's a short paper or what we would have called an executive summary to a manuscript before. So,
But I think that writing is an important skill set. It's part of the larger communications toolkit that, as a teacher, as an educator, I feel that I should impart upon our students. So, in my opinion, it's still important.
yeah, and let me say this too. I think for an engineer being able to put together a engaging, powerful PowerPoint slide set representation or a video, that's equally as important as
Look,
to writing. So I'm
without
not saying that, yeah, I'm not suggesting that it's wrong. I just think that there's value in, writing and describing the engineering procedures that one took or how they did the work and what their findings are. And yeah, I just, I worry a bit about that, but I got
let me,
more
let
important
me
things
add
to worry about.
let me add a couple of words because there's something that I do with my graduate students that I think will serve them well in their future careers. I always ask them, explain to me what you did in a few simple sentences, such that your grandmother, who's not an engineer, I'm assuming that I asked them, was your grandmother an engineer? Okay. But your grandmother, who's not an engineer, will understand what you did. And you have to basically tell a simple story that says, this is an important thing that we're doing because of this. In the past, people have done it this way. I am proposing to do it in a different way. And I've been able to succeed in part by doing this, that, and the other in simple colloquial English.
Yep.
If you are afraid of writing, insert images. You have a picture of the apparatus or equipment. You have some plots that have experimental data. In your mind, you know in which order they go. Sprinkle them in your document, and you will see that filling in the words in between is actually not that difficult.
Yeah, yeah. Well, thank you, Giorgio. I have to close it out here. We always run out of time quickly, but this has been a pleasure. And I'd encourage anybody out there listening to this. I mean, engage with your local universities or engage with universities and research centers. I mean, there's a real opportunity there. If you feel like Giorgio, they love for industry folks to visit, and if not, have a program or something. So, Giorgio, thanks again.
Thank you so much, Mike. Really wonderful. What a great experience. Thank you.
Freight Efficiency with NACFE's Mike Roth and Friends.